Okay, without any further ado, let's get 100 Days of ML started once again. Thankfully, I feel much better than yesterday and the day before. The fever has kicked down, and a lot of the body pain and tiredness has gone away. There's still a little bit of arm pain from where I got the injection, but I'm pretty sure by tomorrow that should be faded as well. So right now it's today is day 44 of 100 Days of ML, and I'm going to be setting up the Docker environment. Well, I'm going to first test locally, but I'm going to be setting up the environment for programming with CUDA. So I'm going to test on local environment, then I'm going to figure out the dependencies required, create the Dockerfile, and then build the Docker image. So the thing is, I'm going to try to test if it works locally, and if things work out locally, I think I might just continue with that. Otherwise, if I decide that it is going to be beneficial, I might just build a Docker container where I can develop CUDA code on it. So the issue with the Docker container might be that I have to do, in addition to just Python, I need other dependencies like C++ and other C libraries, which I need to be careful to figure out. Otherwise, CUDA will not work properly because CUDA is built on top of C, using C, and Python is just an abstractive higher layer that allows people to program in Python, but in theory, it actually runs on C. Okay, so with that being said, let's get started on figuring out the dependencies and testing it locally. So what I'm going to do here is get my iPad, open up the textbook I was reading, which had information on how to get the development environment set up for CUDA on Linux. Okay, so it tells me to install the CUDA toolkit, which I've already done. So I don't think I have to bother with doing that step at least, but I do have to figure out the other steps. I think one of them is pip installing some sort of class. I mean, let me figure out what it is. I think it's PyCUDA. Yep, it's pip install PyCUDA. Okay, requirement already satisfied. Cool. And it recommends me to get like an IDE, but I think I'm just gonna skip that because I don't want to work with an IDE. I don't think it like matters that much. All right, 1 second. I will be back. Gotta do something real quick. All right, back. Let's get this. All right, I'm still reading, trying to figure out. So I got CUDA installed. That's good. Let's see what's the next step. Ensure that we have the right hardware. Got that done. Install GPU drivers. Have that done. Setting up C++ coding environment. So I think I have that done as well, because I have GCC. And I can check, I think. Oh, whoops. How do I check? Well, I have CUDA. I know that. I know I have NVCC. Or how do I? NVCC? Is that the command? NVCC, which NV. So I have it. You can see right there. And I can write a semi. And we get this output here, which is pretty good. Pretty good. It means everything's working. Okay, GCC. How do I check if GCC is working? Let's run GCC-V. Okay, I think I have it installed. 9.3. It says it right there. Okay, so GCC installed, CUDA installed. Recommends some sort of IDE, Eclipse, and graphical dependencies. OpenGL. So I need OpenGL. I don't think I have that installed. So I'm gonna. It says let's also install a few additional dependencies that will allow us to run some graphical in brackets OpenGL demos included with the CUDA toolkit. So it's sudo. I could also open up the GitHub repository and check out like what to install here. Right, so PyCUDA, CUDA, Anaconda, which I'm not going to be using. GCC Eclipse. I don't really know if I need this. Scikit CUDA. I'm not sure what this is either. But what they said, let's just have this installed. Update. Let's update first. Always update before installing. And then sudo apt get install glu t3 dev libxi dev new dev. Okay, with that finish. All right. Okay, testing PyCUDA. So what I have to do is DeviceQuery. So this is a Mandelbrot code for chapter 1. Currently chapter 2, which is, I don't think it's that. Yeah, I need to run this. Okay, let me go ahead, open this up, and in 100 days of ML, I'm going to create a new folder. I'll name this CUDA CUDA. Should I just call it CUDA? And then new file. Let's copy over this code right here. This is just for testing, device querying. And I'll call this DeviceQuery.py. So navigate to that directory. Okay, this is the wrong directory. So I need to do the part 2, and then I'll name it CUDA. All right, awesome. So now it should work. And then I just have to, I just have to Python and then run the file. Oh, this, okay. I do have some fixes to make because this is written in Python 2. So stuff like adding brackets around print. And also whatever other bugs that might come up. I'm gonna have to fix it. The book is written in Python 2.7, which is kind of annoying because it's pretty old. CUDA device query. Invalid syntax. Right, and you have brackets here as well. If this still doesn't work, I'm just going to reverse all changes and then just go back to Python 2.7. Otherwise, I'm going to keep having to do this throughout the entire book, a series of learning. I think it's just going to be much easier to just reverse. Where is this occurring? GPU.get add device attributes. drv pycuda.driver. Okay, this is actually not my, it might be library related error. So let me check that out. Okay, this is Python 3 related. Where was it? Here, I have to use items instead. Okay, so it's kind of working. I mean, it lists my GPU, 3080, the total memory, compute capability, but something happens here. Line 35. CUDA cores per MP. Key error 8.6. There's no option for 8.6. So I think that's why I'm getting the error. Let me check out what this means. Wow, that's one of the issues here as well. They have 7.5. Did I spell however wrong? Oh, it wants me to add a comma. Okay. I think that's a normal error then. So I'll just assume that everything's working and move on. So everything works locally. The thing is, do I want to set up the Docker container with Python 2.7? And when I was searching this up, I haven't found anything very useful. So I want to first check if what Python CUDA uses at the moment. So let's check out CUDA and see if they're okay with coding in Python 3. Because if they're okay with coding in Python 3, I'm just going to continue with Python 3. It makes no sense for me to version back to 2.7 and have to deal with that. I'd rather instead just learn how to do it in Python 3. Okay, that's Python 3 syntax. And I think even in CUDA, they were talking about numba, so I have to figure out what numba is. Yeah, right, so something with numba. I mean, what I could do is just create it, like a create a Dockerfile. And if I really want to use it, I could use it. So let's see here, they're using CUDA 10.2. Does that even install Python? I don't like this because of the fact that there's so much custom, like, if we take a look at this, I'm pretty sure he references to the Anaconda repository. Like, what is Miniconda? Miniconda is never referenced anywhere in the book I'm reading. I know how to use the GPU within a Docker container. I just don't know how to set up a container for CUDA specifically. Let me check out. Okay, first thing, I'll have this open. And then I'm going to check out Docker, NVIDIA Docker containers. So I can use their Ubuntu 20.04 because I'm pretty sure that's what my system is running. Yeah. Their base version as my base Docker image. And then build upon that. So let's go ahead and create an Dockerfile. And I'll call this, so I have to do from, and then this. And I'll have to set up my work directory in a similar way that I set up text classifier. So let me take a look at how I built the Docker containers here. So I'll add a work directory. And I need to add requirements to txt. Pip install requirements.txt. So our text classifier, I can call this CUDA, and then, I don't know, programming or something. In my requirements.txt, I can include stuff like TensorFlow and PyCUDA. Just start with PyCUDA, I believe. That'll be fine. So I'll leave this for now, right? But I don't think I'm going to use it. I have just because like the local version is currently working, and I think I'll just continue building and testing code locally until I run into issues where I can no longer do that. So what I'll do tomorrow is code up the Mandelbrot set and also start testing with CUDA. So it says read. Instead, I'm going to do the Mandelbrot set. Push all this another day. Or actually, because this is going to be fairly simple. It might only take like a 5-minute, it's like a 5-minute job. What I might do is read chapter 3, figure out the tutorial they're going to use in chapter 3, and then combine that with the Mandelbrot set. Yeah, I think that's a better idea. Because Mandelbrot should only take a few minutes. And either way, chapter 3 is going to be talking about how to parallelize the Mandelbrot set programming code. So what I'll do is on 46, I have DFX transform. Then maybe 47, I'll code up the Mandelbrot set. So I have a lot of parallel things going on right now. What I might do is just, if this TFX component, however I decide to troubleshoot it. So the thing is, I'm using the ragged tensor, right? The ragged tensor takes into consideration of variable length strings, and that's what I figured out so far. I think the way to solve the problem is by either using a padding, constant padding, or I might substitute the entire tokenization, custom tokenization part using Keras text vectorization preprocessing function. This might solve the issue. I have to check how the input data is being fed into the model. So if that works, what I might do is finish up the ML pipeline and then continue with CUDA and put CUDA on pause. If it doesn't work, I'll continue with CUDA, give it some time for me to sink in and develop another solution before going forward. So I think that's pretty much it for today. So I ended up testing the local environment, got that working. I installed all the dependencies, also created a Dockerfile just in case if I needed to, and got the DeviceQuery.py working, which has code to basically test the GPU that's installed on the device using CUDA. List out a bunch of, I guess, components, like such as the name, compute capability, and total memory. And I guess the only part that wasn't working was CUDA cores per MP, but I noticed that there was an issue on their repository where someone else had brought up a similar issue with the value of 7.5, I believe. So I think that's a common occurrence that they haven't fixed yet. Okay, so I'm gonna update my code here. In my repository. Okay, well, that'll be it for today.